Good morning. My name is Mrs. Anna Rivera, and I have been a teacher here in Florida for the past 11 years. For the past 7 years, I've been teaching online at our district franchise. I'm currently doing training for our teachers that are learning to be online teachers right now. So that's what I'm doing now, but I've been teaching geometry now for 11 years. Needless to say, it is one of my strengths. So I'm here today to show you just a small piece of it, which is trigonometric ratios. So I'm going to go ahead and share my screen with you. Okay, and as I prepare this, just wanted to prepare you. This trigonometric ratios is just a piece of trigonometry that you will see in geometry on high school courses. Okay, so if you're a student taking geometry and you're learning about trigonometric ratios, this is an opportunity for you to prepare for upper level math in trigonometry and calculus, or even dual enrollment, which is college level courses. So this is just a little piece of it. I'm going to show you some of my tricks and I'll review some of the vocabulary, and then we'll just do a little bit of practice during our 3 to 5 minute demo session. Okay, so let's first talk about the pieces of the right triangle. These are the actual names of the triangles. So do you see this little box here? That little box represents a right triangle, 90 degrees. So anything and everything we're going to be talking about during this demo session is all about right triangles. So if it's not a right triangle, we won't even be bothering with it today. So you will see this little right angle there in every single triangle. There's 3 words that you should be aware of: opposite, adjacent, and hypotenuse. Hypotenuse, not hippopotamus. Opposite, adjacent, and hypotenuse. All of these words are in reference to the angle that's labeled. Usually you'll see a letter or you'll see a number. So if I say opposite, it's opposite to that angle. Okay, it doesn't touch it. It is opposite to that angle. Usually I like to put a little star there. Adjacent means next to, meaning it's next to that angle. It's touching the angle. It's actually part of the angle. That is the adjacent. Then we have our hypotenuse. Our hypotenuse is the longest side length of the triangle, but never assume that just by the picture. You never know. It is always across from the right angle. That's how you know. It doesn't touch that right angle. It's always across from it. So those are the 3 words that you should be familiar with, as we're going to continue to use those words when we do our practice problems. Okay, so we're going to go ahead and go to the next slide. There we go. Okay, so these are some of the, this is a way for you to remember these ratios. So if you've ever heard your teacher say SOHCAHTOA, SOHCAHTOA is a way of you remembering how to write out a ratio for these problems. So would mean the sign is opposite over hypotenuse. Let me go back. There we go. So we have sine is equal to opposite over hypotenuse. Cosine would equal adjacent over hypotenuse. And our tangent is opposite over adjacent. So that's why I said those words that we just used are so important, because now you're going to have to be able to recognize what's what. And remember, it's always in reference to that angle. I'm going to keep putting a star there because that's going to be what we're going to be looking at when we're talking, okay, where's the opposite? It's across from that angle. So if we were looking at this example here, this little image, that's a symbol for delta. Usually you'll have a number or a letter there. So we're going to use the delta as our example when we put our star for the angle we're using. So if I were to ask you, where is the opposite to this? What would you think it is? It's across from that angle. So we are going to put an O there just so that we remember that that 5, that PQ segment is opposite to that delta angle. Our 12 would be adjacent because it touches that angle. And then our 13 is across from that right angle, so that's our hypotenuse. So that's what I like to do first. I like to label it because what happens when you're trying to find your ratio for sine, if it's opposite over hypotenuse, you just look at your O and H. So it's 5/13. What about our adjacent? Well, that's going to be 12. That's our adjacent over a hypotenuse, which is 13. And then our tangent is opposite, which is 5 over our adjacent, which is 12. Then you've got your ratios. Okay, so hopefully you understand that. Obviously, if we were live, I would totally ask you, do you have any questions? Let's go over it and let's review it. So that would be how you use the acronym SOHCAHTOA. All right, so now let's do a couple of practice. Okay. Here we go. All right, let's get my cursor back on there. So what I would like to do with you now is just practice some of these to write a ratio. So if I were looking for this angle right here, that's where our delta is right here. That's where I'm going to put that star. I am only going to label the ones that have a number on there. So we have 12 and 13. So where is 12 in relation to this angle? Is it opposite? No, because that would be the opposite. It doesn't have anything, so we're not even going to mess with that, but we're not even going to label that. This 12 is our adjacent because it is touching that angle. And it's not the 13 because that one is across from the right angle and it's larger. So that's going to be our hypotenuse. So if we remember our ratio that was on the previous slide, SOHCAHTOA, I'm going to write it up here for you. So you remember our sine, our cosine, and our tangent. Okay, sine, cosine, tangent. The O represents opposite, the H is hypotenuse, and the A is adjacent. So if we have A and H, if you look right here, A and H, we're going to be using cosine. So when I write my ratio for this, I am going to put our cosine of delta, because the delta always goes next to sine, cosine, tangent. It's always the angle. And that's going to equal our A over H because that's our ratio for cosine. And then I can just plug in whatever information I have. So our cosine of delta is A, which is 12, over H, which is 13. And that's it for this type of problem. All I want you to do is just show me what the ratio would be for these questions. So we'll do number 2. If our angle is right here, and I'm going to go back to my blue. Here's our angle delta. This is our opposite. This is our adjacent. So if we have O and A, we're going to be using O and A. We're going to be using tangent. So tangent of the delta is equal to our ratio of O over A. And then we can just plug those right in. So we have 4 for O, 13 for A. And that is our ratio for tangent. On to number 3. Here's our angle. So it's not our opposite because this side would be our opposite. So we have our adjacent, and this is across from that hypotenuse. So this is our hypotenuse. A and H is C. So that's our cosine again of our delta. That's A over H. That's our ratio for cosine. Now we're just going to go ahead and plug in our H, which is 6, over our H, which is 9, and that is our ratio. And last but not least, and I will go ahead and conclude this demo session after number 4, we have our angle here. This would be our adjacent because it's touching the angle, but it's not across from the right angle. And this is opposite. So we have O and A. Once again, O and A is tangent. So we will use tangent of delta is equal to O over A. And now we can just plug that in, just like we did the other ones. So 11.9 over 10. All I'm doing is plugging in. And that's it. That's how you write your ratios. So in a live class, we would have other types of questions, probably some more challenging questions. We would work together, we can work in groups, and just practice these questions so that you're ready for when you go back to class. So hopefully that was clear. If you have any questions, please reach out to me. I hope to see you soon.